Hello.
Yeah, start.
Yes, okay. So, yeah, now we'll start with Shivam. So,
Yes, sir.
yeah, Shivam. Yeah. So, a small brief introduction about yourself and yeah, then we'll continue.
Good evening, sir. My name is
Yes.
Shivam Kumar. I am from
Okay.
Samastipur, Bihar. I have completed my BTech, BA College of Engineering and Technology, Jamshedpur.
Okay.
I have a total 3.10 year of experience in memory layout and analog layout.
Okay.
Currently working in ARF Design Private Limited,
Okay.
located at Ranchi. I have worked
Okay.
on memory layout,
Okay.
handling custom layout to backend QA check, handling EMIR, antenna check, race check,
Okay.
LBS DRC extractions, and other check. Work with work with Synopsys tool and closely work with in Synopsys client. In analog layout, I've worked on so many blocks like level shifter, uh, doubler block, PFD block, and other circuit also. In this, my responsibility is uh, area estimation, check means matching device and sensitive block and the shielding net, and also discuss with the designer and our layout lead to specify and understand regarding means shielding and matching, and which metal will use for power routing and signal routing, and which metal will use for matching device writing. And yeah, that's it, sir.
Okay. So you have 3.10. So that is
Yes,
close
sir.
to 4 years of experience in memory
Yes,
and
yes, sir.
analog layout.
Yes, sir.
Okay. So which clients did you work for
In
and which nodes?
memory in
Which
memory
node?
memory
Yeah.
fully worked with Synopsys tool and the Synopsys client,
Okay.
and tool is using 5 nm, 12
Okay.
nm, 14 nm, 22 nm.
Okay.
And in analog layout work with one client is C speed. This
Okay.
is US client, and technology node is 3 nm.
3 nm. Okay. So
Yes,
we'll
sir.
start with EMIR. So can you explain about EMIR? What is EMIR and how do you fix EMIR issues if you faced in layout?
Actually, the gradually movement of atom is called EM. There are two type of EM: depletion of atom and deposition of atom. Okay? And we can fix EM, increase the metal width, go to higher metal layer, add via and use parallel strap, and go to the higher metal layer. In EM, in EM and IR are not fixes in the same way. Some fixes are overlap, like use widening metal, adding via and go to the higher metal. But in EM, we mainly focus on reducing the current density and means for long term reliability issue. And that we use means use current splitting and use shorter metal. But in EM you can use EM in IR mainly you can reduce current, reduce resistance and stabilize voltage. That reason we use power grid and decap.
Okay. So between EM and IR, what will you fix first? If you have two
Yes,
issues,
sir, both
EM issues
fixed.
and IR issues, which one will you fix first and why?
First fix our IR issue, then we go to EM, because IR is a power issue, and if a chip if means device is not reach proper voltage, then it's not turning, then it's not work properly. And EM is long term reliability issue, and EM is a long-term reliability issue, and IR is a short-term issue. Okay, and that reason we can first fix IR and then we go to EM.
Okay, let's say I have up to metal M5, completely a metal stack. Okay, now I
Okay.
cannot go beyond M5 metal also, and I cannot increase the width of the metal also. Okay,
Okay.
and I cannot add more metals. Parallel routes also cannot be done. I have EM and IR issue. How will you fix it?
In which metal EM and IR is coming?
Oh, all the metals are there.
All the metal. Then we check the placement of the device and routing of the and check the routing.
Why?
I think actually if placement is not proper,
Okay.
then this is coming, and we can try to shift the some signal routing and put the and add the strap.
Okay. So what kind of strap will you be adding? Now I told you that there is no metals can be added, can be removed, nothing. Everything is fixed. You cannot do anything. But in that case,
Then we can for EM issue we can use means shorter wire. We can check the connection of the device, and if a device is placed in means device connection is so far, then we can change the placement and put the device near to the connection. Okay, that in this case connection is shorter, then EM issue is gone, and IR is also gone.
okay. So can you explain about STI? Why STI is used, and what are the consequences of STI?
It is a means sorry sir, not recall properly means exact what.
Okay, that's fine. Do you know about LOD effect?
Yes sir.
How does LOD effect occur?
Sir, LOD effect is a it is a means it's a layout effect. It occur when means uh, in order to separate active OD, we have to induce SiO2 layer as a dielectric to isolate the active OD. It extracts the pressure the edge of active OD. Okay, it extracts the pressure of active OD. That reason it's occur. For remedy, we can use dummy of the devices, and it's a change the means threshold voltage. For remedy, we use dummy of left and both left and right side.
Okay. And yeah, so the analog blocks you have worked on is voltage regulator, no?
Yes sir.
Okay. I have a current density of 25 milliamps. Okay.
Okay.
So
Okay.
what are the possible metal stack? How do you distribute this current? I have 400 pass transistors for the regulator. Okay. How do you distribute this 25 milliamps of current for this 400 transistors?
Sir, every metal have carrying current capacity is different. First, we go to DRM and check the current carrying capacity of each metal, and then according to that, we can you can use the metal width, and we can distribute, sir.
Okay, yeah. So, what is the consideration? You as a layout engineer, how will you approach this? I'll
Sir,
be
your
giving you a
voice.
block. Hello. Yeah.
Yes, sir.
I'll be giving you a block. Okay, to do a pass transistor routing with current EM calculations. Also, I require. So I have 25 milliamps of current. So how do you approach
Yes, sir.
this layout design with respect to placement? How will you place the transistors, and what are the considerations for this?
means in this case we can first make a colon of like it means devices, all devices 400, right? So then we can place means like we can make a colon of 40 devices, yeah, small, and then we can means and take a vertical routing of each transistor and put a via, and we can repeat it. Means use a like we can need to calculate, sir.
Yeah, that's what. That's how do you calculate? How do you do that calculation?
Means here 200 here 25 milliampere, right, sir?
Yes, yes.
Can I take a pen paper, sir?
Yeah. Okay, so Pankaj, yeah. Shivam, you can go on mute and yeah.
Okay, sir.
Okay, Pankaj. So just give me a brief introduction about yourself and yeah, we'll continue. Pankaj, you're on mute actually.
Hello.
Yeah.
Good evening, sir. I am Pankaj Kumar. My education qualification is BTech from RBS CET Jamshedpur with Triple E department. I have completed my BTech in 2022. After completion of BTech, I am joined the ARF design company, and since then I am working here. I have a 3.5 year of experience in analog layout designing. Currently, I am working in TSMC 5nm, but I'm also working TSMC 3nm, 12nm, 45nm, 130nm. Thank you.
Okay, so what are the blocks that you have worked on?
Mainly say TX block, TX and sub blocks of RX.
TX and RX.
Yeah.
Okay. Yeah. So can you explain how do you do the placement for main driver in the TX block?
So first we look at domain and schematic guideline, and after that dump the device in layout window and decide the area, and create a rough floor plan and decide the area, and decide the pin direction, and try to solve base DRC, and after the creation of base DRC. First, we review our senior, and after that, routing, LVS, and other verification check.
So what is the critical thing that you'll consider in the main driver? What is the important thing that you have to consider in the main driver?
The main things is actually some matching concept.
And
Matching concept and shielding.
shielding. Okay. Why matching? What are the components in the main driver? Why do you need that matching?
Mainly, sir, component in driver component. I'm not recall it right now, but means mainly means if differential amplifier or current mirror cases, we use a matching.
Okay. So on the TX side, what are the blocks do we have?
In TX, sir, actually means HBM driver, pre-driver and other block, control logic, data generator, driver and pre-driver.
Okay. So
In TSMC 5nm, main 4 sub blocks of TX, data generator, control logic, driver and pre-driver.
okay. So can you explain me first can you list me the layout dependent effects, and then can you explain me one by one what are the layout dependent effects we have?
Okay, in layout dependent effect, first antenna effect, EMIR effect, LOD effect, well proximity effect. These all are layout dependent effect.
Yeah, can you explain me about these effects?
Okay, first we explain antenna effect. So antenna generally occurs in gate terminal of the MOSFET, because in gate terminal SiO2 layer is present. Actually, due to during ion implementation, during etching, metal accumulate charge, plasma etching, mainly plasma etching, metal accumulate charge, and this charge can discharge through gate oxide and hence damage the gate oxide. This effect is known as antenna effect.
Okay, so how do you prevent antenna effect?
First, we use a metal jumper, and other method is use increase the gate area, means insertion of dummy, and other is use the antenna diode.
Okay, why do you insert dummy?
Insert dummy because we try to increase the gate area. Actually, sir, according to the antenna ratio, we can able to say our gate is affected by antenna effect or not. So means insertion of dummy increase the gate area, and antenna ratio is reduced, and our gate is means not affected the antenna effect.
Okay, so I'll give you two options now to fix antenna issue. One would be adding antenna diode, and other would be adding dummy. Which one do you prefer?
First, normally first we prefer antenna diode, using adding antenna diode.
Why?
Generally, most of the time we use antenna diode or means metal jumpers. Most of the time we use metal jumper.
Yeah, but I'm giving you the scenario that to add
Okay.
dummy and to add antenna diode, which one do you prefer to add and why? You said we'll add antenna diode. Why is that antenna diode and why not dummy?
No, sir. That time we use dummy, sir, because
Dummy.
it is very easy to. Yeah.
Okay. 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 So you worked on TX block, right?
Yes.
Yeah. So what are the critical components in TX block?
Sir, in TX mainly some special native project like TX, Astent PD, Astent PU, Padding A, Padding B, and other block out DRB. That time it is the critical net, so that time we use the shielding.
Since
Hello?
you're talking about shielding, right? So what are
Yes.
the types of shielding? And yeah, can you hear me? Yeah.
Yes, sir.
So what are the types
Generally,
of shielding we have?
generally two type of shielding, sir. First one is parallel and second one is coaxial shielding. Yeah.
Okay,
Most of
explain
the
me
time
about
we,
these two.
yeah.
These
Most
two
of the
shielding.
time
Yes.
we use parallel shielding because
Mhm.
in case of coaxial shielding, metal requirement is high, fabrication cost is high, and capacitance is high. That's why I prefer of parallel shielding most of the time.
Why cap is high?
Because in coaxial shielding, metal is more. It means close the all four side, and in case of parallel shielding, only two side. Metal is only two side.
Okay. Yeah. Yeah. Just wait for a second.
Okay.
Okay, Shivam, is it done?
Hello?
Yeah.
Yes, sir.
Yes.
It's done, sir.
Yeah.
Sir,
So
suppose our current is 25 milliampere, then we can divide it 25 divided by 400, and we can calculate the current of each device. Okay. Then suppose use M1. Suppose current carrying capacity is 0.2 0.02 milliampere. Okay, then we can multiply by current and air metal one current carrying capacity. Then we can means like suppose per device current is 6.25 milliampere, and then we can multiply by 0.02, and it's 0.12 micrometer width. Metal width is 0.12.
okay. Okay. Yeah. So okay. So do you know about matching techniques, right?
Yes, I know some matching.
Okay. So I have a current mirror A, B, C. Okay. A, B,
Okay.
C, D.
Okay.
B is my diode device. It has two
Okay.
multipliers, two fingers.
Okay.
Okay. And
Okay.
A is around eight multiplier, one finger.
Okay.
Okay, and C is 16 multiplier, 1 finger,
Okay.
and
Okay.
D is also 8 multipliers, 2 fingers.
B, right?
D.
D.
Okay.
And
I want
B is
you.
B is diode, right, sir?
B is diode.
Okay.
Okay. So again, B is 2 fingers, 2 multipliers.
Okay.
A is 8 fingers, 1 multiplier.
Yes,
Sorry,
sir.
one finger, 8 multipliers.
Yes, yes, sir.
Okay, and C
Yes, sir.
is 16 multipliers, 1 finger,
Okay, sir.
and D
D is
is 8 multipliers, 2 fingers.
2. Okay, sir.
Okay, give me the best matching pattern for these. At least 2 matching patterns, 2 set of matching
Okay, sir.
patterns. Okay.
Okay, sir.
Yeah.
Okay, sir.
Okay. Yeah. Pankaj. Yeah. Shivam, you can unmute yourself. Yeah.
Okay, sir.
Yeah. Oh, Pankaj. Yeah. So, what are the important blocks in this one, RX side? So we were discussing on that. So can you explain me what are the critical components there? You're on mute, Pankaj. Yeah.
Hello.
Yeah.
Sorry. Hello. Sorry, sir. Actually, RX in a Smith trigger is an important block in RX, sir.
Okay. Why?
Because a Smith clean up noisy signal by clean up the noisy signal. The heart of the
Have you worked on CDR?
CDR.
CDR.
No, sir. Sorry.
Okay. No issues.
CDR or DDR?
CDR, clock data recovery.
No, sir. Sorry.
Okay, that's fine. Okay. Can you explain the second order effects of a MOSFET? Second order effects of a MOSFET.
Sorry, sir. Not recall it right now. Actually, not recall it right now, sir.
Okay. No issues. No issues. Okay. So yeah. So we worked on 5 nanometer and 3 nanometer, right?
Yes, right.
So what was the highest gate length in 3 nanometer?
Generally, in 3 nanometer, most of the time most useful gate is 0.0554 in 5 nm 0.055.
Okay.
And highest is other is 86 0.054 and 0.086 and minimum gate length is 0.006.
Okay. So
Highest,
yeah.
yeah.
What is the difference that you see between thin gate device and thick gate devices? What is the layout difference that you see? How do you approach thin gate device layout design and thick gate layout design?
In thin gate device, sir, current capacity is more, sir, and high voltage device, sir. And in case of thick, means low voltage device, sir. Thick gate device is a low voltage device.
But yeah, what are the additional layers that you see with respect to thin gate and thick gate? Do you see any additional layers, or will it be the same?
In generally VT layer, low LVT and SBT, ULVT layer is in case of
Except
thick gate.
we'll not worry about VT layers. What other things that you will see difference?
Generally, sir, a thick gate means is a low voltage device. In case in low voltage device, thick gate is present, and high voltage device, thin gate is present.
Yeah. Okay.
Other thing I not recall right.
Okay. Which clients did you work for with ARF?
Synopsis, sir.
Synopsis.
Yes, sir.
Oh, okay. So you what are the different types of matching patterns?
Generally, sir, two type of matching. First one is interdigitation, and second one is common centroid. In case of diode connection, we use a interdigitation, and in case of differential pair, we use a common centroid matching.
Okay. So do you have pen and paper?
Yes.
Okay. I want a diff pair matching.
Okay.
A equal to 3 multipliers.
A is equal to 3.
3 multipliers, 3 finger.
Okay.
B equal to 3 multipliers, 3 finger.
Okay.
Yeah. Can you do the matching pattern for this?
Matching common centroid or interdigitation.
So, I mean, yeah, what do you consider for diff pair? What set of matching pattern will you consider?
Diff pair in common centroid.
Yeah, you'll do common centroid.
Okay.
Okay. And Shivam, is it done?
Yes, sir.
Okay, can you show it to me?
Yes, sir. So first we can do in means like one row. First we can place means this is our common center. Then we can first place actually diode is 2 multiplied by 2 finger. And place 2. Okay, and it's a 4. Then we place 2 device of A, and then we can place 4 device of C. Then we can place 2 device of D. Okay, and then we can place again 2 device of A, and again 4 device of C, again 2 device of D. Okay, then this is the current mirror means mirror of again in means right side. One is this one, and one is means like we can place in like both means in like this way. Can place like BB, and we can place like say A,
Okay.
like this.
Okay. Wait a second. I'm seeing. Okay. 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 So you have done it in all in single row itself.
Yes, using single row and double row.
On 2 rows. Okay. Now another thing. A equal to 8 and B equal to 9.
Yes, sir.
Can you do matching pattern for this?
A equal to 8 and B equal to 8, right?
B equal to 9.
B equal to 9.
Yeah.
You can use sir like use option, right?
Yeah. Take your time. That's fine. Take your time.
Yes. A.
Yeah. Pankaj, is it done? Yeah, you are on mute.
Hello.
Yeah.
Hello.
Yeah.
Yes, sir. First, sir, yeah, here place 2A and B, then A, and other row B, AA, and BB.
So how many devices are there?
6.
6. 3 multiplier, 3 finger.
Yeah.
Okay. So I have 6 devices. So okay. Okay. What could be the other matching pattern? If you want to still optimize this, how do you approach?
Sir,
Yeah. Just a minute, Shivam. Yeah. So yeah,
sir,
Pankaj.
actually, finger is 3 and multiplier is 3, means total active poly is 9. So that time we prefer this type of 1 A, B, A, B, this type, sir.
Okay, can you show me for this matching pattern about the gate routing? How will you do the gate routing for this?
Sir, in middle, use a 2 input signal, means gate signal. First one is suppose A and B. A device gate is connected to A signal and B is connected to A.
Can you do the symmetrical routing for this pattern?
Yes, sir, here cross the A and B, it means cross type of shape created, sir. This is one A and B. This.
Okay. In fabrication,
Yes.
what is the need for annealing?
Annealing.
Annealing.
What is annealing, sir? I don't know, sir.
Why do we do annealing process?
Annealing process. Sorry, sir. Annealing. What is annealing?
Okay. Okay. No issues. So it is a process that where we'll heat up the metal so that it will return back to its original state. So that is one thing through annealing
Okay.
process. Okay. No issues. Yeah. Okay. What are the currents for your RX block? What are the current carrying capacity for the driver?
Driver generally current capacity is written in schematic guidelines, but I think it's 0.328 in RX. In RX, current unit of driver unit is I think 0.328 milliampere.
Okay. Okay. Yeah. Okay. Shivam, can you show me?
Yes, sir.
Yeah.
Yes, sir. In the first row, A B A B. In our right side, A B A B. In below you can go B A B B A B B, and total B is total 9, and 1 2 3 4 5 6 7 8 9. In place of B we can add on dummy of both side, mean left and right side, and we add dummy and dummy.
Okay. In this, all drain and sources are shared properly with A and B. Is the sharing properly done?
Yes, sir. Inside matching device, one means like source is common. Then source is merged, sir. In this case, generally in matching devices, in matching means source is common. That is all source are merged.
Okay. Okay. So, in which year did you pass out your engineering?
2021, sir.
2021.
Yes, sir.
Oh, okay. Okay, Shivam. That's it from my end. Yeah.
Thank you, sir.
Yeah. So, okay, Pankaj. So,
Okay, sir. Thank you.
yeah.
Yes.
So, can you explain me about the fabrication steps? What is involved?
Yeah, first is wafer protection, epitaxial growth, photolithography, masking, etching, doping, and ion implantation. Hello?
Yeah, yeah. Okay.
Yeah.
Yeah. So, yeah, that's it, Pankaj, from my side. Yeah.
Okay, thank you. Okay, sir. Thank you.
Yeah.
Yes, sir.
Hi, Soshish. Hello.
Hello.
Yeah. Yeah. Hi, Soshish. Yeah.
Tell me.
Yeah. Wow. Pankaj and Shivam's is done. Yeah.
Done, na?
Yeah. Yeah. Done. Done.
Okay. Okay,
Okay.
just write me and send me the feedback, okay?
Okay. Yeah.
I
Sure.
will send you it.
Okay.
Okay. Okay.
Okay.
Thank you, sir.
Yeah. Thank you.
Okay. Bye, everyone.